Okay, so welcome back. Now, this is part one in a fairly brief series, I believe, where we're going to learn about a device that is used absolutely everywhere in the commercial world, the industrial world. Power company uses them everywhere. In fact, the power lines that feed your home or office, it's pretty much guaranteed that the power company is using relays to monitor those power lines. And it's the job of the relay to detect if something's going wrong and then to open the circuit breaker that will turn off power to those lines so that whatever problem it's having, it will go away and somebody can go out and fix the problem and then turn the power back on. But it's the job of the relay to monitor 24/7 electrical power lines, and if something bad happens on the power lines, it's the relay's job to detect that, say, hey, something's going on, and perform some action like open a circuit breaker to de-energize that line. So we're going to look at a relay, we're going to look at how it works, and as part of this series, we're going to do what we usually do on this channel to really learn about something, either an engineering or science concept. One of the best ways is to sit down and try to write a software simulator, because if you really want to learn how something works, writing software to simulate that requires that you actually figure out what's going on inside the device or in the scientific concept and put that into code, write some equations and really understand what's going on. So as part of the learning process here, is like we always do, we're going to write a software simulator like you see here, and we're going to simulate a simple overcurrent relay. So here is a simple block diagram of an overcurrent relay and how it works. What you can see here is it, as we mentioned before, it monitors, in this case, the current in a circuit. You can see the amps coming in on the left, and an overcurrent relay will monitor 24/7. It will monitor the current coming in, and what it will do will say, well, that current, is it okay or is it too much current? And if it's too much current, that implies something's going on in that circuit and you need to do something because it could cause, a fire, it could cause other problems. So it's really important what the relay does. It says, is that current good or is it bad? And the way it does that is it uses what's called a fault detector. It detects whether there is a fault in the circuit. And to do that, it takes the incoming amps, compares it with what's called a minimum trip setting. So for example, if the normal current on that circuit when everything's normal is 2 amps, then you might set this minimum trip setting at 2 or 3 amps, and anything more than 2 or 3 amps is going to say, hey, wait a minute, that's too much. I need to do something. So the fault detector says, okay, that incoming current, is it too much or is it okay? If it's too much, what it's going to do is it's going to start a timer. And the timer is going to basically say, if that current is still bad after 1 second or 2 seconds or 5 seconds or whatever, then I need to do something. If the current goes away, then that's all right, we don't need to do anything. But if the current is still there after whatever time delay, I need to do something. And generally what it will do is it will open a circuit breaker to de-energize, to disconnect the electricity from that circuit. So your power company, for example, will have a relay back at their station down the road from you. And if a tree branch falls in the power line and causes a short circuit with a lot of current, it will sense that, and after a certain amount of time, it will open the circuit breaker and you'll lose power to your house, as will your neighbors, right? So it's a very simple concept. It checks the incoming current. If it's still there after a certain amount of time, then it will do something. Now, this is very similar to the way a fuse works. Now, I did a video a while back explaining stuff that a lot of people don't understand about fuses. I encourage you to take a look at that because it will explain some of the details of how relays work and why they work that way. For example, you can see I've got a timer. A lot of people think that this time delay is always constant. In fact, for reasons that I explain in the fuse relay, the time delay depends on how much current you've got. So for example, for really high input currents greater than the minimum trip, it's going to go a lot faster. It's going to trip a lot faster than for if you've got a minimum trip setting of 2 amps and you get only 3 amps coming in, it's going to take a lot longer to trip. And the reasons are explained in that fuse video. So I encourage you strongly to take a look at the fuse video to understand why there is a variable time delay dependent on the current. So what we're going to do in this series is we're going to develop this application you see here, which is simulating a relay. And it's going to, over the COM port, it's going to take information in from our bench, where we're going to measure current in an Arduino and a current sensor. And it's going to continually measure that current and display it on this text box. And if the current exceeds our minimum trip, which you can see down here, minimum trip is 2 amps. If it exceeds 2 amps, it's going to start timing. And the time is going to be based on what's called the curve type. And this we'll talk about in a bit. It explains how fast it goes depending on the current. And also the time dial. We'll talk about that in a bit. But basically it's going to measure the current, and if the current exceeds a certain amount of amps for a certain amount of time, you're going to see down here the breaker, which is normally closed, will go open, and that's how we're simulating the relay. Now also we're going to include functionality called digital fault recorder. You see this button that's grayed out here, DFR or digital fault recorder, where if we do get an overcurrent, it starts timing out and then trips, we're going to record over time, and we're going to put out in a chart, we're going to show what the current was over time. That's really important also because, if this does trip, you're going to want to go back and figure out and troubleshoot why did this happen. And it's really nice in the real world to have a chart showing what was the current versus time, so you can understand, was it a whole lot of current for a short time or what? And that'll help you figure out what happened in your circuit. So we're going to develop this application to help us better understand what a relay is. And we're going to use as an example a relay similar to this. And this is a relay offered by what's called Schweitzer Engineering Labs. This company was basically the first company to invent a microprocessor-based relay. Previously, relays were electromechanical, but when microprocessors came out in the early 80s, they developed the very first microprocessor relay, which you see here. And this is probably the most popular relay in the world. They're used absolutely everywhere. And they have a whole lot of functionality. And we're going to use this as kind of an example, see how it works, and we're going to apply that to our software simulator. So now we said that one of the functions of the relay, the overcurrent relay, is to, once it has determined that the current is above a normal value, it needs to figure out how much time to wait before it actually trips the circuit breaker. And that depends on how much current. And we said, again, I encourage you to look at the fuse video where we explain these what are called inverse characteristics, which basically say down at the bottom we've got current in multiples of pickup versus time on the vertical scale, time in seconds. And these are called time current curves because it's time versus current. The greater the current is going to the right, multiples of pickup, the faster the relay will operate. So, for example, if it's a 2 amps pickup and you have 2 amps in the circuit, you can see the multiples of pickup down here is only 1 time, so it's probably not going to operate. Only when you get up to around 1.5 times, so I'd have to go from 2 amps up to 3 amps, 1.5 times, and then the relay will start to operate. And if I go up to 10 times or 20 amps, it will operate a whole lot faster. Now we can also see that there are multiple curves here, and these are different time dials. So not only do you have the characteristic here that it goes faster with more current, but you can also specify what's called a time dial to make it go longer or shorter for any particular current. We also have down here different types of relay characteristics. On the one on the left, this is called a moderately inverse curve, or a U1, and that's using IEEE notation. We have an inverse, which is a U2, which goes faster at high currents. And then we have a very inverse, which goes even faster at high currents. and an extremely inverse, which goes super fast at high currents. And that all depends on your needs. And again, I encourage you to look at the fuse video to explain these inverse characteristics, time current curves. So what we're going to do is we're going to figure out how can we model these time current curves in our relay. Basically, we need to be able to put in a current and get a time as a result. We need to look up in these curves. So how do they generate these curves? This is one reason why it's really nice to write a software simulator, because you find out that there's actually equations that define these curves. And I'll scroll up here and you can see here are the equations associated with these US curves. And depending on the type, moderately inverse, inverse, very inverse, extremely inverse, or short time inverse, you have these equations. And the operating time is basically the time dial times this number, 0.0226, 0.0104 over m, which is in the multiples of minimum trip. So for example, if I have 3 amps and it's 2 amps minimum trip, that's 1.5. Raise that to the 0.02 minus 1. So all we have to do is we have to put these equations into our simulator, depending on what type, whether it's a U1, 2, 3, 4, or 5, and put in these equations based on what time dial we want, and also what's the actual multiples of minimum trip, and that will give us how much time it should operate in at that current. So now here is the circuit that we're going to use to feed current into our software simulator. And this is comprised of 3 components on my bench. I've got my DC power supply, which goes 0 to 10 amps. And I've got a current sensor, which we did a video before. It's a very nice current sensor. You can feed it up to 10 or 15 or 30 amps, depending on the model. And it will give you a 0 to 5 volt output proportional to the input current. So you can do very high currents and give you only a 0 to 5 volts proportional that you can feed into Arduino. We've got this Arduino that's connected via USB COM port to our computer. And our software simulator is going to get the values read by the Arduino, and we're going to request every time step, like a tenth of a second or whatever, from the Arduino, say, hey, read the voltage coming from the sensor, convert it to 0 to 1023, and we're going to use that in our relay simulator software. And we're going to take that current, put in the relay logic, and we're going to be able to, in real time, check the current and see if it's too high. If it is, it will go through the relay logic and ultimately trip the relay. And we'll also use that to record the data so you can go back later on after the relay has operated and see what actually happened, and we'll have a chart of the fault. So here's our simulator. I open the COM port to connect to the Arduino. I have set the curve type to inverse. I can choose very inverse or extremely inverse. I've set the minimum trip to 2 amps and the time dial of 10, and I'm going to start the simulation. And right now it is reading in real time the amps coming from the Arduino through the CZH current sensor. And now what I'm going to do is I'm going to turn on the power supply, and now I'm going to crank it up, and it's going to 1 amp, 2 amps, 3 amps, and the relay has just picked up and started timing. And we're up around 4.8 amps, and you can see that the relay is timing, and when it times out, it's going to open the breaker. And it's just timed out, and it gives you the time delay that it took the relay to operate, and that is the basic functioning of the overcurrent relay. Now also I've included functionality of a DFR digital fault recorder, and I can click on this. It will open up a chart and it will give me the actual current flowing through the circuit until the point that the relay operated and tripped the breaker. You can see it started out at 0 and up to 2.5 and down to 0 and back up to almost 5 amps and then tripped. So this is the basic functionality we're going to include in our software simulator. And again, it's a great opportunity to learn about C#, Windows Forms, and also about real-life devices and how they work. So now here's the overall setup we're going to be looking at in the future videos. You can see I've got my power supply on the bench, it's turned off, and I've got on the bottom left, I've got an Arduino. You can see the blinking lights. It's updating our application that you can see here every 1/10 of a second or 10 times a second. And then in the center bottom, I've got my CZH current sensor that's getting current from the power supply. And then I've also got a wall wart power supply that's feeding the current sensor. So you can see that I've got 0 coming out of the DC power supply, and my application is reading just about 0 or 0.1. So what I'm going to do is I'm going to turn on the power supply, and you can see how simulated overcurrent relay will respond. And you can see the relay is timing out, and it's got a fault indicator, and at the point that it trips at 4.86 amps, and there you go, you've got the relay has tripped based on the 4.86 amps. So in the future videos, we're going to show how to develop this application. So if you like any of these videos, please hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.